So next we will study about the reactions of metal, and you may have seen the rusted iron or silver when they get some gray color, or Statue of Liberty which have all green color. So these color on the metals shows some reaction is going on with these metals. So let's see what type of reactions occur on the metals. Mainly there are two types of reaction happen. One is called oxidation and second is reduction. Oxidation reaction is defined as a loss of electron from the metal is called oxidation. So metal tend to lose electron to form cations. For an example, sodium we have seen in the first column in the periodic table. It readily loses one electron and it becomes sodium plus, like this one. So metals tend to lose the electron to form cations, and that reaction is called oxidation. So loss of electron is oxidation. We abbreviate like LEO. Leo means loss of electron is oxidation. So you can memorize or from this abbreviation Leo and GER, which means reduction, and reduction means gain of electron. So whenever in any metal loses the electron, the other species take those electron, so other species get reduced. So reduction, gain of electron is reduction, and GER came from G gain, E is electron, and R for reduction. So non-metal tend to gain the electron to form the anions. For an examples, chlorine gas or chlorine atom. Let's write chlorine atom plus electron. When it takes electron, it form chloride minus chloride ion. So this reaction is called reduction. So reduction of chlorine. So you can remember this metal reactions from this phrase, Leo the lion says gear, means loss of electron is oxidation and gain of electron is reduction. So we'll see one examples to understand this better. So reaction of metal with an acid. So whenever a metal react with the acid, it forms salt and hydrogen gas evolve. So when iron elemental form, which have zero charges, when react with sulfuric acid, it form iron sulfate and hydrogen gas. So hydrogen gas have zero charge, and now iron have zero charge here, but when it is with the sulfate ion, it become positive charge because sulfate has 2 minus. So iron has a 0 charge initially and 2 plus charges at the end. So 2 electrons have lost. So iron lost 2 electrons, minus 2 electron. That is why iron oxidation. So this reaction is oxidation for iron. And hydrogen has plus 1 plus charge initially and have 0 charge at the end. So 1 electron per hydrogen has been gained. So this reaction will be reduction. So this will be 2 hydrogen, 2 electrons which iron has lost, and those electrons were gained by hydrogen. Then 2 hydrogen, the positive charge will convert into 0, and the reaction will call oxidation. So you can see this oxidation and reduction reaction are happening together whenever reaction happens. So one species get oxidized and another species get reduced in the oxidation and reduction reaction. So basically oxidation and reduction reaction occur simultaneously. In another example, this aluminum, when they act with copper chloride, it become copper 0 and aluminum chloride. So aluminum have 0 charge initially and a 3 plus charge at the end, because it is attached with the chlorine 3 chlorine. So 3 electrons have lost, so aluminum have lost 3 electrons, minus 3, and copper have 2 positive charge initially and a 0 charge at the end, so 2 electrons have been gained, so that will be reduction, plus 2 electron. So copper chloride is reducing and aluminum is oxidizing. And so these two. So here is the example of reaction of metal and a salt. So we have seen two examples, when a metal react with the acid, another is metal react with the salt. So these were the examples of the oxidation and reduction reaction. And next is the activity series. What is this activity series in your periodic table, in your book? So this activity series predict whether a certain metal will be oxidized either by acid or particular salt or not. So you can see this series is called activity series of a metal in aqueous solution, and there are some certain metals are listed here, and each metal is listed in oxidation reaction, in the form of oxidation reaction. Means lithium solid is losing one electron, become lithium plus. Potassium solid is losing one electron and become potassium ion. And like a gold 3, platinum 3, mercury. And here is the written also hydrogen. So this is kind of boundary line from the hydrogen, and then below, and then hydrogen line, and then up above. So we'll explain more. And this big arrow says that ease of oxidation increase. Ease of oxidation increase means as you will move from bottom to up, the loss of electron is easy. So lithium will easily remove the electron compared to aluminum, or potassium will easily remove the electron compared to calcium. Same way, copper will lose electron comparatively harder than chromium. So if we will move down from top to bottom, loss of electron is not easy. And if I will go from bottom to up, so loss of electron will be easy. So oxidation reaction will become easy. So how to understand this activity series? So metal which are higher in the activity series are more likely to oxidize, means they are called active metal. So they are very easily tend to lose the electron. And metal which are lower in the activity series are more likely to reduce, less reactive. So the metals which are lower in the series, they have less tendency to lose the electron, but they have more tendency to gain the electron. That is why this is called reduction. And metals at the bottom of the series are very stable and form compound less readily and used to make coins and jewelry. So bottom compounds are like gold, platinum, and silver, copper, rather than mercury, except mercury. So these copper, silver, and gold, they used as a coin and jewelry, but they are very less reactive. And another rule for this activity series is any metal on the list can be oxidized by the ions of element below it. Means if zinc ion can be reduced by calcium. So calcium is easily remove the electron, and that can be absorbed by zinc ion. It means like that. So only metals have hydrogen, only metals above hydrogen in the activity series are able to react with acid or H plus or oxidize to form hydrogen ion. So here is the activity in the activity series. You can see the hydrogen is here. So metal above the hydrogen, they are only those react with the acid. So metal below the hydrogen, they do not react with acid to produce hydrogen gas. And metal below the hydrogen in the activity series are not able to react with acid and not able to oxidize. So these are the properties of the activity series, and as we will see some more example, we will understand this better. Here is one more example is given: oxidation reduction reaction. When silver nitrate in aqueous solution react with copper solid, it produces copper nitrate and silver solid. So you will notice when a copper wire is placed in a silver nitrate solution, and over the time it what happened in the reaction, silver here is a +1 charge because of the nitrate, and copper is in 0 charge. And now here you can see copper is in +2 charge because of that there are two nitrate, and silver is in the 0 charge. So silver become from +1 to 0, means it is accepting electron. And if you remember, GER, gain of electron, is reduction. So silver is reducing, and copper is from 0 charges to +1, means it is it is accepting this electron. So silver nitrate is accepting gain of electron is reducing, and copper is losing one electron, so it is oxidizing into copper ion. So here this reaction shows that when silver nitrate, they are in the aqueous solution, and this is copper. So copper is oxidized, basically it is losing the electron, and silver is reduced to gain the electron. So you will see copper and silver ion in the solution, and since silver is gaining the electron from the copper, so silver is sticking on this copper coil. So this was one example of oxidation reduction reaction, and let's see one more example, the redox process of in compound reaction. When magnesium and oxygen react, so what happened, magnesium usually whenever react with oxygen, it form magnesium oxide. This crystal structure shows MgO. So here magnesium have 0 charge, but when it is in with the oxygen, it is in the +2 charge. So magnesium is losing the electron, 2 electron, and oxygen is gaining 2 electron. So magnesium is losing the electron, means oxidizing, so it is oxidized into magnesium ion. So So here is one thing, formation of an ionic compound, how the formation of ionic compound form like this way, and the formation of covalent compound, for an example hydrogen and chlorine. So basically when they react together, they do not transfer the reaction and the electron, they just share the electron. So hydrogen have one electron, and in this case this is the diatomic hydrogen, and this is a diatomic molecule of chlorine. So two chlorine are sharing one electron here, and two hydrogen are sharing one electron here. But when they react together to form hydrogen chloride is, this shows a small ball and big ball for chloride ion. So hydrogen ion and chlorine have more electron pulling properties, so that is why it gain minus charge and hydrogen gain positive charge. So this is a polar molecule, polar compound. So this was about the oxidation reduction reaction, and we will see some more example in the next slides. Let's see the another problem, practice problem in the oxidation and reduction reaction. Predict the product of the following reaction. If no reaction occur, write NR no reaction. So here is aluminum. When react with copper chloride, it form aluminum chloride and copper 0. So if you see the charges on this aluminum is 0. All the element which are in without any sign plus minus, they are in 0 charges, and from 0 to it is going to aluminum chloride. So aluminum chloride, there are 3 chloride, and each chloride has -1, so there will be -3, -1, -1, -1, so there will be -3 charges on total for 3 chloride. To balance, then this each aluminum has 3 plus. So you can see each aluminum is losing 3 electrons, means it is oxidizing, and each copper 2 plus is going to be 0 by gaining the 2 electron. So 6 total electrons lost and 6 total electron gain, because there is a coefficient 2, so 2 multiplied by 6 and 3 multiplied by 2, 6. Another example is this chromium nitrate plus silver, no reaction. Why no reaction? Okay, so once again here you can see why this reaction is happening. If you remember this periodic table, so the position of this aluminum and copper, so let's see where is the aluminum and copper. So aluminum is on the top, and then copper is below hydrogen. So the element or metal which are above the hydrogen, they can easily oxidize by the lower element, means they can easily lose the electron than copper. So this reaction is possible. And on the other hand, chromium nitrate plus silver, no reaction. Why not? Because silver metal is below chromium ion in the activity series. So silver metal cannot lose the electron to chromium. So basically chromium, if you see how many charges are here, each nitrate have 3, or you can move this subscript 3 to on the top of chromium, so chromium must have 3 plus and silver must have 0. So for the reaction, chromium must gain the electron, then chromium will become 0, and then silver must lose the electron, then silver become plus. So according to activity series, you can see the silver, and where the chromium is here. So chromium can lose the electron, but it cannot gain the electron compared to silver. Silver can lose electron, but very slow. I mean, it cannot, it is considered as a inactive metal than chromium. So here chromium have already in the positive charge, it cannot further lose the electron because this is already in the ionic form. So this is the reaction type of example where you have to learn some more problem about the activity series.